Hello students. So let's continue with the topic motion. In the last lecture we left on the topic three equations of motion. Let's cover these three equations in today's lecture and they're very interesting, don't worry, and you will understand them easily. Three equations are of motion are very easy and very important. Why? Because they are used in numericals. Okay, and how they are used, let's understand that part. Okay, basically first let's go with the first equation. First equation of motion. All right. So now the thing is very simple here. You can see this person. Okay, if he moves from point A and reaches to point B. All right. From here, he reaches to point B. And in this position shift, he took suppose t time. But initially, this is its starting point and this is its final point. Even at the start, let's consider its initial velocity is u. And when reaching at point B, his final velocity is v. Okay, so what are these initial and final velocities? And he took time t. Now let us understand this with the help of graph and try to deduce first equation. Okay, using graphical method. And it is very simple, friends, don't worry about that. Let's draw a line. On x-axis there is time t, on y-axis there is velocity v. And as I have already mentioned that the velocity is u because it is not starting from 0, it is starting from u. And after certain interval of time t on time axis, the boy reaches uniformly or moves uniformly, or you can say with uniform velocity, and reaches to point B. So let's mark these points as A, and this point can be considered as B. So parallelly you can consider this part as B. Okay, so now what is more important to understand here, this whole line, this line shows you uniform motion of this person, of this boy. All right. So what he's doing, he is at velocity u. After time t, he reaches at point B with velocity v. Okay. So let's understand this and try to remember the formula of acceleration. Acceleration is nothing but change in velocity. Change in velocity over time. Change in velocity over time. So this is the formula that we are going to use here. So A is equals to change. Change means final velocity minus initial velocity. That is v minus u upon. You can also take time as change because initially there was 0 time, then after t it is t. So you can say t minus 0. We can write it as t. Alright. So now it will be very easy to understand. If we cross multiply time to this, what we will get? We will get AT is equals to V minus U. Alright. So next is we can write it as V is equals to, because this is negative here, it will go to the left side as positive. Okay. So don't confuse. Let me write it again. Okay, so simply it is going at this part and I can write it as AT plus U is equals to V. That means I can also write it as V is equals to U plus A into T. This is nothing but the our first equation of motion, and you can remember it easily. There is nothing complicated in it. It's very easy to remember, but if it is not visible, I can tell you it again. V is equals to u plus at. What is v here? Final velocity after a certain interval of time t. U is the initial velocity at which the object or person was already there. So the acceleration came out to be the change in the velocity. All right. So first equation is v is equals to u plus at. Now, what is the use of this equation? Let me tell you that. If we are given the value of velocity, that is final velocity, initial velocity, we know the acceleration, we know the time. So this is the relevant equation. Out of any these four, if there is one missing term, we can use first equation of motion to calculate that term. All right. So that is the use of first equation. Okay. You can remember this. Let's come to the next part. We will continue using the same graph. Okay. But this time we have to consider one important thing, that this person, the boy, is still moving. Okay. The boy is moving, but now we have to calculate the distance. Calculate the distance. How much distance was covered by this boy? So if we have to calculate that, how we will do it? Let's continue with the same graph. I will use this same graph. I will draw it again. Okay. You have to draw it again. Once you practice it at home, you have to draw the graph again. Let's draw it again for equation second. Okay. Equation, or you can say motion, equation of motion, second equation of motion. All right. Let's draw that graph again. Here we had time axis, and here it is velocity. All right. So simply use some different color. I will draw this graph again. This is the actual graph that I have drawn with the red color. Okay. दिस इज द सिंपल ग्राफ, और इस ग्राफ के अंदर आप एक चीज़ बहुत इजीली समझ सकते हो कि ये ग्राफ स्टार्टिंग फ्रॉम जीरो तो नहीं है. ये ग्राफ कहाँ से स्टार्ट हो रहा है? इट इज स्टार्टिंग आफ्टर अ सर्टेन इंटरवल ऑफ दिस velocity. Okay, so this is the gap. This gap is denoted by initial velocity, that is u. जब हमने उसे देखा बॉय को मूव करते हुए, ऑलरेडी ही वॉज एट यू वेलोसिटी. नाउ आफ्टर सर्टेन इंटरवल ऑफ टाइम टी, आफ्टर दिस इंटरवल ऑफ टाइम टी, उसकी वेलोसिटी कितनी हो गई? v हो गई. ओके, ऑलराइट. सो वी ऑलरेडी नो दिस पार्ट. अब एक चीज़ बहुत इंपॉर्टेंट है. आई विल टेल यू दैट a इज इक्वल्स टू v अपॉन टी. ये बाय डेफिनेशन आया है. इफ़ यू वांट टू आस्क सर ये कहाँ से आया है, देन इट इज़ वेरी इजी टू रिमेंबर. ये आया है बाय डेफिनेशन. ऑलराइट. सो एक्सेलरेशन इज डिफाइंड एज द रेट ऑफ चेंज ऑफ वेलोसिटी. That means change in the velocity gives you acceleration. If it is increasing, it is acceleration. If it is decreasing, then it is retardation. Perfect. Okay. So by the definition, if I make you understand very important rule of it, if I draw a graph between velocity and time, then slope of that graph, you have to remember this, then slope of that graph will tell you acceleration. Perfect. Slope of that graph will tell you acceleration. If I multiply this, that is, if I multiply this, and it will be acceleration into time is equals to velocity. So if I draw a graph between multiplication part, if I draw a graph between two multiplier, that means a and t, then area of this graph will tell you velocity. But यहाँ पे तो ऐसा है नहीं. यहाँ पे क्या है? यहाँ पे acceleration नहीं है, यहाँ पे velocity time graph है. So this is one part that you have to remember. Let me add one more important formula that you definitely will see. That is velocity is equals to displacement upon time. I will use the same concept here also. Velocity is equals to displacement upon time. If I cross multiply this, what I will get? I will get velocity multiplied time is equals to displacement. All right, so I will get velocity into time is equals to displacement. Let's understand this. Let me write it on the left. यहाँ पे अगर छुप रहा है तो velocity multiplied time is equals to displacement. Okay, so I have done nothing, but it's a very simple part that you can consider, that the graph between velocity and time. Listen, student, very carefully. Graph between velocity and time and its area will give you displacement. Okay, so what is the graph on the screen that we have right now? The graph between velocity and time. Velocity and time. So its area will give us displacement. This is very important. You have to remember it, make a note of it. Now let's draw this graph and let's dark shade its area. All right, let's shade its area. So what is this area? This figure looks like a trapezium, but we can draw it like this also. The above part is a triangle and the below part is a rectangle. Okay, so now what we have got? We have got displacement. Let's use that. Okay, ready? Let's use that. So displacement, let's symbolize displacement with symbol S. S is equals to area. Let's mark the name of this figure as well. S O A B C D. Okay, so we have to write area of O A B C D. Okay, so what we have to do now, we can break it into triangle plus rectangle. All right, so area of triangle as well as area of rectangle, we will add these two and we will get what we want. Okay, displacement is equals to area of triangle. Let's write area of rectangle first. That is, what is the area of rectangle? Length into breadth. And what is length? Time. And what is breadth? This part. This part is nothing but u. Okay, so it will be u into t plus. Next is area of triangle, that is half base into height. Let's see the diagram. Base. So this is the base. I guess this is the same base that will be shared with triangle, and this will be the height. So this is height is velocity and this is initial velocity. So you can consider this part as v minus u. V minus u. Okay. So I will put it like this, v minus u and into t. Let's simplify it using first equation. Using first equation of motion. And what does it say? We got at is equals to v minus u, or you can say v equals u plus at, because I have written it like this because we need the value of v minus u. You can see it here also. What we need its value. So we can write its value as a into t. Right? So let's use that. S is equals to ut plus half t into at from this equation. Okay, so what we have got, s is equals to ut plus half a into t square. This is our second equation of motion. Very important, very easy to remember. Second equation of motion. Right. So it is easy. What is the use of this equation if you are asked to calculate the displacement? You can solve it with the help of graph. You can solve it with the help of this equation also. And the equation कैसे आई that I've told you with the help of graph. Perfect. Now, what is next part? During this journey, if we have to calculate third equation of motion, that is v square is equals to u square plus twice as. So very easy and very important to understand that we have to understand the concept of average. Okay, so there are two terms. One is instantaneous, second is average. Let's take an example of velocity. We can also use this word for acceleration, but let's take an example of velocity. If there is average velocity and if there is instantaneous velocity, जब आप बाइक पे जा रहे हो आपने स्पीडोमीटर चेक किया, suppose it is showing you 50 kilometer per hour. It is the speed. If you are going in a particular direction, it is a velocity, but it is an instantaneous velocity at that moment of time, 50 kilometer per hour. Got it? If I'm taking entire journey that you started from house, start this bike, took it from 0 to 50, then stayed on 50 for some time, then increase the velocity, increase the speed. There is nothing difference here in the speed and velocity because we are going in a straight line. Okay, then increase the speed till 100, then applied the brake, come to the rest. So this entire journey is now considered, and if you are going to calculate the velocity of the entire journey, पूरी journey में आपकी velocity कितनी रहेगी, speed कितनी रही, then you will calculate the average. Understood the difference? All right. So let us consider that part. So third equation of motion. Third equation of motion. That is very easy, important as well. So इसी के अंदर हम consider करते हैं. So acceleration is equals to you can say total velocity as well. Total. Let's consider it. Okay, acceleration is equals to change in velocity upon time. This symbol means change. This is delta symbol, and this means change. All right. Now, we have to understand that you already know that a square minus b square is equals to a minus b, a plus b. Okay, so if we help you with the easy method, that is v square equals to u square plus twice as. I'm giving a reverse method, okay? It will be easy to remember. Okay. Let's move forward. if I take it on the left, if I take this u on the left, it will become minus. That is v square minus u square is equals to twice a s. All right. And what I have to do next, I'm taking 2 here. I'm taking distance displacement here, keeping the acceleration on the right side. Perfect. All right. So v square minus u square upon 2 s is equals to acceleration. All right. Now I can open it with the help of this formula that I've told you, a square minus b square. It will be a plus b or a minus b upon 2s. Okay, so let's understand this thing is equals to acceleration. We already know, I'm just telling you the reverse method, but you can go upside down, that we have to understand this equation. For that, we have to understand two important concepts. That one is this velocity, that is v plus u upon 2. How does it look like? It is not looking like an average of something. Like अगर दो चीज़ों में हमें किसी को बांटना है, so how do we take the average? Sum of these two divide by 2. Alright, so v final velocity, u initial velocity, adding them and dividing by 2. So it is an average velocity. Multiply v minus u upon s. Okay, so what is this? This is, what is this? V minus u. Remember the first equation, v minus u is equals to 80. But that is again a, but we can't take it. Right? So just understand this part, that acceleration here is average of this velocity using the first equation, and this is the displacement. Okay? So you can understand there are two concepts here that we have to build. One, instantaneous, let's example of velocity, and second is average. All right. So what we have to understand here, instantaneous, for example, there is a complete journey. I'm taking some examples here. This is point A, B, C, D. First, someone is going from A to B, then going B to C, then going from D to C to D. All right. Then, suppose during this journey he is moving at 50 km per hour, here 60 km per hour, here 30 km per hour. So if I check at this particular point of time, then its velocity is 50 km per hour. If I check at any point at this, it will be 50 km per hour. If I check at this point, it will be 60 km per hour. That means at a particular point of time, if you are considering the velocity, then it will be an instantaneous at the moment कि उसकी velocity कितनी है. But if we're talking about from A to D, कि उसकी पूरी entire journey, उसकी पूरी एंटायर जर्नी के अंदर कितनी उसकी वेलोसिटी रहेगी, देन वी विल कंसीडर एवरेज ऑफ दीज टू. एंड हाउ डू वी कैलकुलेट एवरेज? टोटल डिस्प्लेसमेंट अपॉन टोटल टाइम. अब टोटल डिस्प्लेसमेंट सर यहां से कैलकुलेट नहीं होगा. टोटल डिस्प्लेसमेंट कैलकुलेट कहाँ से होगा? फ्रॉम इनिशियल टू फाइनल पोजीशन ओनली. दिस इज स्टार्टिंग पॉइंट and this is final point. So this is the displacement that you will calculate and divide by the total time taken during this journey. Perfect. So you have to revise these all three equations graphically. Definitely, because graphically is more easy than other method. Calculus method is also there, but definitely that is not for ninth class. You can use graphical method, which is easy. And if you have any doubt, you can comment. We'll try to solve. We'll definitely solve in the next video. All right. If you face any problem, feel free to comment. Thank you. Bye. Enjoy